Okay, welcome to Open Source GIS from Field to Server, the British Columbia edition. So we're doing this series across the country. I thought it would be nice to sort of split it up and do this webinar a few times. This would allow us to show some demo data from the local area, which we'll be doing shortly. So what we're going to be doing is running through this demo. Going through, sorry, I just have to deal with something. Somebody thought they can't hear me. 1 second. Holy moly, sound issues. Okay, so welcome, and we're going to be running through a whole bunch of stuff today. I just want to give you a little background on our company. So we're Luna Geospatial. We're a London, Ontario based company. We specialize in open source GIS. We do consulting and training, focusing on everything from QGIS to PostGIS, Geoserver. We offer training and ongoing support. We do software development. We build custom web GIS tools and database-driven applications. We also build GIS servers. So we build GIS servers in the cloud. We fully maintain these. We do everything from maintenance of the server itself, software on the server, as well as backups, support, and training for all the software on these systems. We have a range of clients from coast to coast and around the world. We do a lot of really neat projects with people in the conservation sector. We work a lot with nonprofit organizations throughout the country. We do a lot of work with like Birds Canada and other conservation authorities and organizations. We started work recently with the Nova Scotia Federation of Agriculture, doing a really neat project developing a web-based tool to manage all of their farm survey data. This is a fun project, but we also do projects internationally. We work with Ben Gurion University in Israel, doing a project on e-waste in the West Bank area. This is a really neat project as well, where we're serving a bunch of imagery to researchers who are working in the field with a team of mappers. So this is one of the wonderful things about open source GIS, is that it allows us to work in many different sectors, and it allows us to sort of touch on a lot of different things. The intended audience for today, I sort of like to let people know, especially if you're an open source GIS pro, this is really, this webinar is put together for anybody that is interested in open source GIS, but might not be familiar with it. So if you're a super pro with open source GIS and you're looking for some tips and tricks, this is not the webinar for you. This is going to be some pretty basic top level stuff that we're going through. And if you're a public or private organization thinking about migrating to open source GIS, this is a good opportunity for you to sort of hear more about the range of software available for you, and really how we work with clients when we're migrating them over to an open source solution. Note, this will not be an advanced course on anything open source. So that's just something I'd like to let you know before we dive in. If you like this webinar, we do a lot of webinars. I try to do somewhere in the neighborhood of like 6 to 10 per year on a range of different subjects. So some of the ones coming up this year, I think we're going to be doing one a little bit more on multi-user editing using PostGIS, and then there's going to be a few other ones. We're doing one on GeoNode. We're going to be doing one on MerginMaps. So there's a lot of neat stuff coming in. We're doing one on R as well. So if you want to stay in touch, we try really hard not to spam anyone. So when we say sign up to our newsletter, you're not going to get an email every second day. For this, you will get a sort of our monthly, and then we sort of send reminders throughout the month if we're doing webinars, but we try not to pummel you with email. You can also always check our webinars page on our website for any past and future webinars. We have everything up there, so you can go on and check it out. We record all of our webinars and throw them on our YouTube channel, so you'll always be able to log in and go on and check them out if there's a subject that interests you. All right, so let's start. I'm going to turn off my video, and we are going to dive into this discussion with the benefits of open source GIS. So I've been working with open source GIS for well over 10 years. I've set up open source servers for a number of different organizations. I work with it daily. So I get to see firsthand what the benefits are for a lot of organizations. So a lot of this is not, theoretical. This is actually practical knowledge. So I've broken it down. Everybody loves a top 10 list. So I've broken it down to our top 10 benefits of open source GIS. And the first is cost savings without sacrificing functionality. This is huge. A lot of time people think that if they're moving towards open source GIS, well, they're not going to be able to have as many different functions. There's not as many tools that they'll be able to use. That's completely false. In my experience moving to open source GIS, the bigger problem is figuring out which one of the tools you want to use to solve a problem. What's the best one of the many options that are available? I've had clients sort of moved over to it. I've never touched something like spatial SQL, and next thing you know, they're migrating all of their workflows to spatial SQL and doing everything within the database. It can be a lot of fun. No license restrictions is always huge. Quicker and more often frequent bug fixes. I've had times where, you submit an issue, or I've heard about friends who've submitted issues to the QGIS team, and next thing you know, within a few days, the bug is fixed. And especially if it's something that's affecting a lot of users, if something has been released and somebody realizes, oh, WMS services are freezing up the system, then we can always, submit a request and submit a bug. And next thing you know, these things do get fixed. What I think I really like about open source GIS is the organization-wide access. You don't have to worry about things like seats for the software. If you have somebody who might use it once every 3 months, you don't have to worry about paying for an additional license to have that person give that person access to your GIS. So it's a lot more open. We can customize. If there's a custom toolbox you want, or a tool that you want within QGIS, we can build that, and you can have that within the application. Large supportive user group. In addition to the support that we offer, there's tons online. It's really rare that you could even Google a problem and not find somebody who's had the similar type of situation and can offer some advice. As I said first, more tools. There's just tons of tools. There's tons of new things coming out, new functionality. One of the neat things about QGIS in particular is that, it's funded by a bunch of different organizations that will develop different tools. It's crowdsourced. We're building tools that people want. So if you want something to process 3D point clouds, then that tool is being developed by somebody, which it has quite recently. Interoperability. I get this a lot. I get, well, if we move to open source GIS, what are we going to do with all of our data now? Well, most likely it will either open within something in QGIS, we can load it into a database, we can load it into Geoserver. It's very, very rare that I stumble upon some sort of file format, either a raster or a vector, and think to myself, shoot, I can't load this in QGIS, or I can't load this into the database or do something with it. It's very rare that happens. Extensibility. We can we can customize the existing tools, but we can also extend it. We can build additional things onto the application, which is a lot of fun. And enterprise features. This is built for an enterprise environment. I've done a couple of webinars talking about the enterprise features within open source GIS, and there are numerous, right, in terms of connecting to the database, data security, and so on. And the big bonus here is documentation and other resources. I think one of the big myths about open source GIS is that, there's a lack of documentation or a lack of support. And that's completely false. It's complete BS, because if you go onto any of the mature software like QGIS, PostGIS, Geoserver, you're going to find not only end user documentation, you might find tutorials, you might find training manuals, and all these things are maintained over time by the development team. It's really a great resource. All right, so what does our open source stack look like? Well, you could probably imagine, we build everything in the cloud with an Ubuntu server. It's one of the top flavors of Linux on the internet. QGIS is a powerful tool. Our main desktop application that we use, of course, when we're connecting to anything within our server. Postgres is our top relational database management system. So this is where we house all of our vector data. And PostGIS is the spatial extension for Postgres, and it allows you to PostGIS allows you to load spatial features within the database, and I'll get into that in a few minutes. Geoserver is great. It allows you to share raster and vector data on the web quite easily. And MerginMaps. So it's a mobile data collection platform. And this is something that I will be talking about and giving you a little bit of a demo at the end using some data from Kamloops. And lastly, a lot of clients will build this platform. They not only want to connect to it using QGIS, they want to have some sort of custom web GIS. So we have something we call LunaMap that we use as our platform to build these web GIS applications. So if there's something custom you need, if you want to load layers and you want to be able to click on things and it open up this thing, we can build these types of tools. And this is what we do for our clients. So what does this look like when we put this all together? Well, the center brain of our server is Postgres and PostGIS, our database. This is where all of our vector data lives. And this connects to Geoserver. Geoserver is where we put all of our raster data, and it can also connect back to the database and serve out vector data through Geoserver. And typically we're serving this stuff out to the web. So we can use something like GeoNode, or we can build a custom web-based application with leaflet or open layers. And we could also do this. So some of my clients do this, is that they'll share data out to their clients. So if they need to share the data directly to clients, they can do that through Geoserver. They can set up the security policy and so on and share the data out. Now, I mentioned this already, the most popular way of sort of connecting to our servers will be using QGIS. So QGIS allows you to load your vector data, your raster data, and so on. But there's still that importance of having some sort of file system where you can store stuff. Now, there are times where if you're going to be doing any analysis on, let's say, raster data, you're probably going to want that to live in some sort of local file system, whether it be on your computer yourself or on a file server within your organization. So we never truly move away from that, but the sort of center brain of your GIS becomes the database and Geoserver, while anything that you're sort of working on, if you're working on some sort of large data set or you're processing, doing 3D analysis on some large terrain, that might happen more within the file system, but the finished product, let's say those contour lines or something that you've developed, those will move into the database to be used throughout your organization. So the happy people who connect with QGIS are your staff. Now you could actually if you had clients or outside organizations that need to connect to your data, you could also give them access via QGIS. We've set that up for people in the past as well, but we just sort of need to lock down permissions. And one of the most beautiful applications out now that's built with open source software for the open source community that connects nicely to QGIS is MerginMaps, and this is a mobile data collection platform. And we're a partner with MerginMaps. So we sort of help companies and organizations throughout Canada to adopt MerginMaps. We provide training and support, and you name it, what you might need. But this makes your staff happy because now they can create mobile apps, go out into the field, and be very happy collecting data and bringing it back in. Now, MerginMaps also has a really fun tool called MerginDB Sync, and we will often throw this onto a server, and this will allow you to sync data from your mobile data collection platform directly into your Postgres database. So at this point, you could then have something like, okay, people are collecting something in the field, we're going to be syncing it automatically into our database, and then we're going to be serving it out to the web via Geoserver. So we have that full circle from field to server to desktop. So open source GIS implementation, what does it kind of look like? So when we're going through this process, we go through a server configuration process, we install whatever software, set up the web GIS, do anything we need. We do the database development. We design schemas, tables, trigger functions, all the various objects that have to exist within the application, and we design the user permission system for the database. Next is a big part, is where we do data and workflow migration. So for data migration, we simply gather all of your vector data, all of your raster data. Vector data goes into Postgres, raster data gets optimized and thrown into Geoserver. We also migrate workflows. So this is where we sit down with a client and we'll go through, what do you do on a daily basis? What do you do every 3 months? What are some tasks that you need to do that we need to replicate within this open source environment? Now, at times we actually will move that directly into something like spatial SQL and say, you know what? It's nice that you're clicking a bunch of tools to do this, but I can also write a script for you that does everything you need automatically. And all you have to do is open up a table and it's done for you whenever you need it. So we go through that process with the clients, and we also look at any ETL scripts. So if you are sort of loading data from a third party, we might set up something in the database to pull those data in automatically. Training is a big part. I like to make sure that anybody who moves towards open source GIS, that they have the tools, the knowledge they need to be successful. So we offer a variety of courses, everything from like intro or advanced courses in QGIS, PostGIS and QGIS in an enterprise environment. Just this allows you to figure out how to use PostGIS within QGIS, intro to Geoserver, intro to MerginMaps. We do some sysadmin training. If you do have a system administrator on staff, we can sort of teach them how to interact with this server if they need to. And we also like documenting. We document all of your workflows. We document anything that you need to bring over into this system. Second to last, we go live. This is where the fun part, where we open it up to the client and everybody can start happily using the server. And then we proceed to support. So we offer ongoing support when we're setting up these servers via email or virtual meetings. It's not uncommon that I'll sort of jump on a meeting, or one of our support agents will jump on a meeting with somebody to solve a problem. One of the things that's nice about our support is that we do this. I've been in that position where I work for a small or medium-sized organization, and we don't want to take on a big support contract. We just kind of want support when we need it. So we have sort of like a pay-as-you-go system for support, where we pay into it and we just eat away at the hours over time. And we do that at 15-minute intervals. So if you have a quick little question, that's 15 minutes is we're going to take to sort of solve this problem. And we manage the server, so everything, the backups, the upgrades, and everything like this. So what do we use? Well, for desktop software, I'm sure we can all guess that QGIS is our starting point when we're loading everything up into the system. When we want to connect, QGIS has amazing features, powerful cartography and spatial data management tools. The processing framework has hundreds and hundreds of tools. We have 2D and 3D tools without restrictions. This is really nice. I think we've all been in that situation where, a bunch of people need to do some sort of 3D analysis, and there is only one license or two licenses for a certain extension. We don't have that problem within QGIS, because every seat will have access to every tool, of course. Some great tools for creating, editing, and managing data. The basic editor as well as the advanced editor is really nice features within QGIS. I did a webinar on plugins, which is actually my most popular webinar that I did. I didn't think it. I just sort of put together a webinar on like my top 10 favorite plugins that I use within QGIS, which turned into something ridiculous, like top 18. But plugins are huge. This is that part about how open source GIS is extensible. You can build onto it, and through the QGIS plugin market, you're able to build custom tools. Even like large companies have tools that they've built for QGIS, which is pretty amazing. So check out that webinar if you want to see a little bit more about plugins. One thing that's really nice if you're doing, high-level analysis, there's support obviously for Python, R, spatial SQL directly within QGIS. The graphic modeler is great for you. This is what you see in front of you right now in this little screenshot. You can put together custom tools and save those as tools and execute them within the processing framework. Integrated Python console and spatial SQL support, of course. Additional support has actually been released in the latest version of QGIS. I don't have it on my system just yet, but this allows you to do point cloud processing within QGIS. So this is adopting some of the tools that we'll see soon from PDAL. Saga, don't judge it by its logo. Saga is actually a very powerful remote sensing and spatial analysis platform. It is a full set of GIS tools, and it is something that I have used quite a bit to do analysis. It can do both raster and vector analysis. And again, please don't judge it by its 2005 style. And there are literally hundreds of spatial algorithms within this application. And there's some of them that you would sort of expect to find in kind of expensive proprietary software, but they're available for free within here. It's a modular framework, so there's always new things being added to it. And so some of the modules include things like terrain analysis, simulation, image classification. So if you're doing any type of image analysis like classification, this is an app you definitely use. One of the things nice is that if you have it set up properly within QGIS, all of the tools are integrated directly within QGIS. So you don't even need to open up Saga. You can just use the tools via the processing toolbox within QGIS. Now, similarly, GRASS is well integrated within QGIS. So GRASS also has a ton of raster and vector tools. They're built into 350 core modules. These tools work within QGIS, so you can actually string them together with some native QGIS tools and do both vector and raster processing. So some of the stuff that I've done before with GRASS is some specialized remote sensing tools for things like Landsat processing. Some of the modules also are handy, are things like the network analysis module. I use that as I was studying food deserts at one point, and I use the network analysis tool in here. They're very handy. I've also used the LiDAR processing tools to process some point clouds. And again, these tools are fully integrated within QGIS. GDAL is the basis for all image processing. So it's another desktop-based tool that you can use. It's the most widely used geospatial library, I would say. You can use the command line interface. Once you have QGIS installed, you're going to find something on your system called the OSGeo4W shell if you're using Windows. And the tools are available, of course, within QGIS, as well as, the tools are available in pretty much every other GIS software that's out there. It's sort of what works behind the scenes when it's doing any type of raster analysis. Used in everything, ArcGIS, QGIS, Google Earth, Saga, everything uses GDAL, but the tools can actually be called within the QGIS processing environment here. Because, again, fully integrated within QGIS. So PDAL is the point data abstraction library. So it's kind of like GDAL, but for point data. It translates and manipulates point cloud data. Very handy to have if you're working with any type of data, if you've collected either LiDAR data from a drone or you've collected LiDAR data from an external sensor. It is really easy to set up pipelines with readers, filters, writers, and so on. It's a handy way to process LiDAR data, and you can create things like DSMs or DTMs. Really nice in the latest release, as I mentioned, this is now integrated within QGIS. So there's actually like GUI tools that you can use to set off some PDAL scripts. All right, so that's desktop. So desktop gives us access to a whole bunch of software. We can do a whole bunch of different things. There's rarely something that I encounter where I'm like, oh, how am I ever going to process this stuff? But it's quite easy to use all of the software. There's a lot of documentation. It's very easy to sort of get into it. So what about server software? Our starting point when we're setting up a server is, of course, Postgres with PostGIS, the spatial extension. Postgres and PostGIS really combined turns this into a spatial database. Postgres was developed since 1996 and PostGIS since 2001. So these are very mature pieces of software. This isn't something that was created last week. And Postgres is really one of the most widely used relational database management systems in the world. Spatial SQL, so PostGIS adds hundreds of additional spatial functions and geometry types and a whole bunch of other goodies within the database. It allows you to really do, it's been described as a GIS in a box, and this is exactly what it is. I like these sort of simplified backups and restorations. This is something we do as part of for all the servers that we manage, is that we run backups on a regular basis, and we can always restore. We work within a cloud environment, so it's very easy to restore, grab data if something has been deleted. by mistake. Very powerful permission system. We can be very granular with how we grant permissions. And I've done a few talks on this before that you can see on our YouTube channel, including talks on things like audit tables and different types of permissions that we can enable within the database. I love automating. I think that whenever I can automate something within the database, I do that. And we can do that via trigger functions or other types of stored procedures. And this really makes our life easier because you could have a series of fields that automatically get populated whenever you do something like draw a polygon. The nice thing about Postgres and PostGIS is that it's really well integrated within the QGIS environment. We have default symbology that can be saved directly within the database. We have full database management via the database manager. You can run complex queries with Database Manager. So you can do all this directly within QGIS. And it's really cool that you can run a query, and you can see this again. I've done webinars on this before, where you can run a query and then load the results directly within QGIS as like kind of like a query layer. So you can also use the database layers with QGIS tools. This is really handy because you can use the native tools, run analysis on it, and then save the result directly within the database. It's a really handy way of managing this. And one of the things I really love, you can save QGIS projects directly within the database. So if you're creating something, and I'll show you this soon, what we've done with the demo data. If you've created a project, you can save that directly in the database. It's centralized. Anybody within your organization can then open up that project. Well, I really like how we can manage authentication within QGIS. That's a really nice integration. So however you've set up permissions within the database, that is reflected within how users can interact with data within QGIS. So if you're a read-only user, well, that editor button is not on. You can't edit the vector data, of course, because the database will throw you an error. Search and zoom with the Discovery plugin. One of my favorite plugins. You can search through layers and set this up so that it searches road names or parcels or water courses or whatever you want. And it's just a really handy way of doing search and zoom within QGIS. So another application that we install on the server is Geoserver. Geoserver has been in development since about 2001. It permits sharing and editing of geospatial data over the internet. So we're going to look at this a little bit today, just on how we use Geoserver. I use Geoserver mainly when we're spinning up a server for raster data. We serve vector data as well if we're going to be serving it out to the web, to one of our web applications. We can also use it to serve out vector tiles. You can even use it to serve out cogs if you want and things like this. Has the ability to connect to a variety of different data sources. So again, you can connect to your database, you can throw shape files in a folder, you can connect to other WMS services, you can cascade WMTS services from other servers. So if somebody has something even like an Esri server with a WMTS endpoint, you can cascade that through your Geoserver, which is really handy. There's a lot of extensions that support different types of databases. So things like Oracle, SQL Server, DB2, and so on. Those external services can also be served through Geoserver. So you can also connect to other OGC compliant servers. So things like Map Server and QGIS Server can also cascade through here. Okay. WebGIS, this is where it gets fun. So at this point, if we're thinking of setting up our server, we have all of our server stuff set up. We have our desktop environment with a whole bunch of software and access to a billion tools. What do we want now? We want a WebGIS. So WebGIS software, it comes in many shapes and forms. Leaflet is something that we use quite extensively when we're developing web-based applications. It's been in development since about 2011. It is a framework, so it's a JavaScript library that's used for web mapping applications. It is also integrated really nicely into QGIS. There's a plugin called QGIS to Web, and this allows you to export whatever view you have to a sort of web-based application. It's kind of like a basic WebGIS. So it's kind of neat. It's a neat starting point if you're going to use that plugin to output your data to the web. And then there's another one. There's also OpenLayer. So OpenLayers you might have heard of. It's another application released in about 2006, another JavaScript library for displaying maps on the web. But this one's a little bit more robust. It supports all the sort of same services you'd expect with Leaflet, but there's built-in basic and a lot more advanced tools. So there's a lot of functionality that's already inbuilt within OpenLayers. Very handy to have because it just cuts down a little bit on the amount of development time and effort, because there's often something that's already built within OpenLayers that we can use. We use a mix of both at Luna. If something's a very basic application, Leaflet is going to do it. Even some of the more advanced, it just depends on where that advanced stuff takes place. If it's just happening in a database and we need to send it out and visualize it, Leaflet still works. But if we want to do a lot of stuff in the browser, and a lot of even analysis within the browser, then we'll often lean more towards OpenLayer. So you might have heard of GeoNode. GeoNode is another web GIS application that we use. It's actually technically classified as an open source geospatial content management system. And this is exactly what it is. It simplifies things like user management and data access rules. And it's really a place where you can store all of your geospatial data and make it available either internally or externally. You can have both a private and public portal for sharing your data. You can do things like full text search through data, maps, and documents. What's really nice about this is you can create a lot of metadata associated with whatever objects you're sharing, whether it's a map or if it's a data layer or a document. This full text search allows you to just search across that whole array of data that you might be serving. So again, the data map and document catalog is extensive. You're able to provide tons of metadata associated with it, attach comments and things like this to each individual record. The metadata catalog is really one of the core parts of this application. And it also allows users to download data. So if you have the data marked as downloadable, users can come in. If it's public, they'll just be able to come in and download the data. So this is a really nice platform to build something like an open data catalog. And this is something that we set up for clients so that they can do exactly that. Share data, collaborate. I have one client who's using it to do collaborative mapping on the web. So some of his clients can log in, they can mark something on the web, on the map, and he'll be able to see it immediately. It's really a cool platform. They have an integrated web GIS as well within GeoNode. So this allows you to view your layers on the web, style them, and you're able to also create things called GeoStories, which allows you to sort of string together a bunch of different maps and some text and sort of tell a story with a map. One of the final things that's really neat about this is its integration within QGIS. So anything that you share within GeoNode, you're actually able to access that also through QGIS. So here in the browser panel, you're able to access GeoNode. And if you have your connection set up, you're able to see a number of different layers that you have within GeoNode. So we build a lot of custom web GIS applications. So this is one we built for a client. It's fairly straightforward. It allows you to do a whole bunch of different things. And one of the things that's nice about custom is that we can change it and build it and do really whatever we want with the application. So we can toggle layer. It supports WMS, WMTS, WFS, and so on. We have a base map switcher. You can do basic search and zoom on any layers. You can identify feature like what you're seeing in front of you now, where you can click on a parcel and it will tell you some information about that parcel. You can filter features. You can do custom print layouts. This is one of the things that's really handy for clients, is that you can print directly from the web. We have GPS tools. So this can be used in a number of different ways. It's typically a lockdown service, so only logged in users can see it, and you can go out, and if you see something like, oh, there's a broken fence, you can mark that on the map, and that will live directly within your central database. We have public and private tools. Those allow us to turn things off. So if there's any layers that you don't want to see publicly, we can turn them off. And as well, tools. Oftentimes a client might want a very simplified web GIS. Okay, we just want them to be able to toggle layers and search for a location. We can turn off all the tools so that only a logged in user can have access to those. Login and user management, we're able to manage, create users, edit users, change passwords, do all of that within the app. And we also have a pretty neat share button. So you're able to, when you share, you'll share that exact location with whatever layers have been loaded at the time. Minor little tools like measurement tools. One of the things that how this platform is built is that it allows users to create custom tools, not themselves, but we develop custom tools for clients. So if a client comes and said, you know what, this is great, I want all this stuff, but I also need a custom tool that will do blank. Then we can build that and we can extend this map to allow to have those tools. That's one of the nice things about WebGIS or building custom WebGIS is that we can really make it unique. And the list goes on. All right, so mobile data collection is huge right now. And this has been an ongoing problem within GIS. There's tons of different applications out there. Some of them work well, some of them don't. And you know, you really want to, okay, I just want to create an app really quickly. I want to go out in the field. I want to collect a bunch of data. I want to press a sync button. And I want it to sync back to my server because when I get back to the office, I want to be able to do something with the data. It sounds pretty simple, but technically it's a big undertaking, right? Is that there's a lot of moving parts, there's a lot of syncing. Just imagine, okay, no, there's actually 10 people all collecting data and they press the sync button at the exact same time. What's going to happen? So the people who develop these applications, this is what they're thinking about, is that they're trying to create a solution that will allow them to sync data properly. So to the rescue, MerginMaps. MerginMaps is a great application for doing field data collection. A number of our clients are using it actively, daily, to collect data for their organization. So we can do, it's fully integrated within QGIS. So the way it works really is that you create a project within QGIS, you share it out in MerginMaps, you open up the app on either iOS or Android, boom, you're ready to go. What's nice is you can view your data and location on the map. You can capture points, lines, areas, even photos. You can even scan barcodes and QR codes, and you can sync data with the press of one button. So there's no cables. You don't have to bring your phone back or plug it in and bring it to the GIS person and have them plug it in and pull some data off of the phone. This will all be done seamlessly with the press of a button. One thing that is really cool, you can actually version your data on this. So if people are collecting data and then syncing the data, and you'll actually see the history of data within this application. And this should be very appealing, especially to both public organizations and companies alike, is that you can have unlimited projects, unlimited seats. So really the thing about MerginMaps is storage, right? If you have a lot of very large projects, you're going to have to, the pricing is set up so that you're going to be paying mainly for your storage. But even with the smallest, like the lowest tiers, with MerginMaps, you're still going to have the ability to have unlimited projects and unlimited seats. And with the new sync tool, so there's a sync tool that we can install on our servers. This would allow you to sync your data directly back into your own personal database. One of the things that's really nice too is that what's coming out soon is an enterprise edition. So for a lot of organizations, you have to keep your data within Canada. So what's nice is that you'll now be able to install the equivalent of MerginMaps Team Edition on your own server. So this will live within our Canadian servers, and this will allow you to access the data directly. Also helps you a little bit. MerginMaps servers, I believe, are in Europe. So this is going to help you a little bit with latency as well. All right, so I'm going to talk a little bit about what we did. I wanted to sort of show you how all this fits together in a quick little 15-minute demo or so. So I'll show you a few things that we did. So we put together the scenario where we just wanted to set up an open source GIS server with data that we took from Kamloops, BC. All the open data that we're showing is from Kamloops. We use various raster and data and vector data sets that we obtain from the city, from the open data catalog that they have at this web address. So you can go here and download it yourself if you're interested in seeing it. And of course, a disclaimer of endorsement. LunaGeo has received no endorsement, support, or sponsorship from the city of Kamloops with regards to the public data used in any software or service promoted in this webinar, implied or otherwise. Now I've made the lawyers happy. So basically, we're using this open data to create this, this demo for you. All right, so let's start talking first about migrating vector data. So this is one of the first things. We have the server set up. We're all ready to go. The client has handed us a big pile of vector data, so a big bunch of shape files. What we often do is we configure the database. So in this part, we will typically go through and we will develop the different schemas that we require in the database. Think of a schema as like a file folder. So if I flip over to QGIS right now, we have a variety of different folders here. Well, schemas, they act and look and feel like a folder. You can put data within it. So in the parks and recreation, we have art, culture, education, parks, recreation, entertainment, sports association, and even trees. And likewise in boundaries, we have a bunch of boundaries: the city boundary, the city property, neighborhoods, postal codes, property parcels, and school catchment zones within the city. So one of the big first steps when we're setting up one of these servers is just figuring out, how are we going to organize the data? Where are we going to put it within the database? And we load the vector data via the database manager. So this is a really neat tool that we have within QGIS right here. And this opens up and this allows us to import data. So through the data importer, there's a number of different ways of doing this within QGIS, but I always recommend to clients or anybody new to this to use this. So if I wanted to import, let's say, the city boundary layer that I have loaded right now into the city boundaries schema, I could do that. And I could also specify what I want the primary key to be, what the geometry column to be. I can even transform on the fly as I'm importing data. So if I wanted to transform it to EPSG 3157, I could do that automatically as I'm importing it. Very handy tool, the database manager. And it's what we use mainly when we're importing data, but we can also do it programmatically. So we could run a loop through a folder and just import every single data set that's in there. The next thing we do is create default symbology. So this is where you can see if I'm going to load any layers right now onto this map. I'll load a big one for you. I'll load the parcel data set. So as the parcel data set is loading, it's being loaded with this default style that I've applied to it. So we have this orange polygon outline that's being loaded automatically on the map. Now, we can save that as a default style within QGIS. So when we're in the properties of a layer, we can go through and we can go to save as default, and we can save this style. And when we want to, we will save it directly to the database. Now we can save additional styles. You know, we can save one that's, let's say, a green line, and we can press apply and we can see that, okay, yes, we have this. We can save additional styles. So we can go to save style, and we want to save it into the database, and we want to call it green parcel, and we can save this to the database. This isn't our default style anymore. So if we were to do something like remove this layer and then re-add the property layer, it's of course being added with that default orange outline, but we can go in and we can load a style from the database. And when you do this, you'll see that I've done this more than once. So from the database, we have a whole bunch of styles associated with this layer. We have parcel black, parcel red, but we also have this green one that we just did that turns the parcel green. So with this setup, we can lock this down and we can centralize all of our symbology for our layers, so that if anybody within the organization loads a layer, they're going to load it with that default symbology. It's a very handy tool in an enterprise environment. The next thing is we create projects in the DB. So this is where we start styling different layers, and we can load them and save them. So we created a schema called maps, and we created projects called like Kamloops City Services, and this is a map that's just going to show city services throughout Kamloops. So here we have some bus station or bus system layers that we can turn on and off, and we also have things like our garbage collection zones that we can turn on and off, and all of this is being pulled directly from the database. And then we also can toggle layers on and off. So just like anything else, we can, but the neat thing about this is that we can save these projects centrally. Now, who has access? Who can edit these? This is the big thing, is that since this lives in a database, all of these projects essentially live in a table called QGIS projects. Depending how we set up the permissions on that table, that will allow people to have access or not have access to the projects within this schema. So imagine this, a very common scenario we go through is we'll create the base map for an organization and say, okay, everybody should have access to this, but I don't want anybody to be able to save it except for our GIS administrator. Let's say there's one person who's managing all of the GIS data. They can update it. They can add a new base map if that comes. But we don't want the standard user in the organization to be able to open it and mess around. So they can have print layouts set up. They can have all of this set up within the application, but nobody can actually change it. So it's a really nice way of centralizing not only the data, but projects that use the data. We can create trigger functions as well. I have a little demo layer that I use for this. So a trigger function will automatically, make a few calculations, or it can do really anything, any spatial SQL or any SQL query that you want to run. You can run this with a polygon layer. So when we add this, this is a custom QGIS form that I created. This is something that we talk about quite a bit. So when I set up the symbology for a layer, I might actually set up QGIS forms like this that has a drop down. So we can have existing, proposed, new. I'm just going to leave it as new. And then we can also have a bunch of metadata fields. You can see that a bunch of these are blank. There's nothing calculated for area or square meters or the perimeter. But if I add this, press save, I can turn off editing at this point and come and identify this again. We can see now that the area is calculated, the perimeter, and that's all done within the database. The minute we press save, it is literally that is a trigger function. So the function is triggered and it makes the calculation based on that new geometry. Even in metadata, it tells us that we're logged in with the main admin account, Postgres, and it gives us some timestamps associated with these changes. Really handy tool to have. We use trigger functions all the time when we're setting these things up for clients because it just saves time, right? And it allows you to make sure that the right data is being loaded when we're working with things. Okay. The other nice thing is spatial SQL in the database manager. I mentioned this already, but if you're going to ask a question like how many bus stops are there in each neighborhood in Kamloops, you can do this quite easily. You could run this with QGIS tools or whatever, but you can run this within SQL quite easily. It's a fairly simple spatial join between your neighborhoods and the point layer, which is your bus stop layer. And so basically we're running a select on the name of the neighborhood from the bus stop, which is our layer A, and we're running an intersect. So we're intersecting those two layers and counting them, but we're also doing some fun stuff. We're actually transforming on the fly. They're not in the same coordinate reference system, these two layers. So we're actually transforming our neighborhoods to EPSG 3157. Then we're going to be grouping, and then we're going to be ordering by the name. And the results when we run this within the DB manager is it takes about 14 seconds, which can feel really long when you're doing this in a demo, which is why I'm not doing this live. But the results are that you end up with a count of bus stations within each of these neighborhoods. Very handy tool. Again, spatial SQL. We cover a lot on spatial SQL when we're doing our training. And if there's a client that actually wants to dive really deep into spatial SQL and migrate their workflows, and they know this is what they want to do, which I have one right now in the telecom industry who's doing that. And we help them out extensively so that they can do everything they need to do directly within the database. It's really a great tool to have. Okay, so we've talked enough about vector data. How are we going to be setting up the raster data? So we serve and cache the data through Geoserver, and we can also serve PostGIS data. We also serve PostGIS layers through Geoserver, and we can consume those web servers services via QGIS. So I'm going to show you a little bit on how we do this. I'll just show you this quickly so we can get on some more fun stuff. But we have a number of different aerial photos that we process. So what we did is we downloaded either, like, I think some of them were in Mr. SID format or something, but we converted and optimized everything to GeoTIFF. So now we can switch base maps. So now we're loading the 1999 layers, and this is all being loaded. I don't load these directly for demos. I like people to see exactly how this works in a real environment. So, I'm on a fairly average internet connection, and this server is located in Toronto. So I have clients across Canada using our servers, and our data center is located within Toronto. So there's very rarely any complaints. I think usually when there is a complaint, it happens to be their internet connection and not access to this. It's a very fast server, but we can switch to various data sets. And the speed at which this loads is really dependent on how much cache is built. I didn't pre-render a lot of cache. There's a few areas that I know load fairly quickly because I've sort of panned around a little bit, and you can see the tiles loading as we move in and out. We can zoom right in and it will load the tiles. What's neat about QGIS is that we're loading this as a WMTS service from Geoserver. This will actually cache the layers also locally within QGIS. One of the things that always shocks me is that the amount that organizations will actually pay for an image server. If you had imagery like every 5 years, every 2 years, and you're medium sized to even a large organization, you can serve this on Geoserver. You can serve this on a system that isn't that large, and it really doesn't cost a lot to load. But I want to show you really quickly what this looks like within Geoserver. So if I'm logging in. So if I'm in Geoserver now, I can preview a lot of the layers that I've loaded. So I have that 1999, 2004. So I can open this up and show you a preview of the layer. But what I've set up here is I've set up these tile layers. So I've tiled and cached all of the aerials, or the 4 aerial data sets that I'm doing. So if we're going to focus on like this 2020 RGB, right now we have 148 megs of cached imagery stored on the server. What's really neat is that this caches on the fly. So if I was to sort of zoom out to an area and then maybe zoom into an area. So remember, what were we at? 148 or something. If I start zooming into a new area, it's actually generating those tiles right away. So if I come back here, we're at 148 and refresh this page, now we're at 152. So as I'm using it, it's generating that cache, and that just speeds up performance. The next time you come into this area, it's not actually making that call. Actually, in QGIS, it's not even making the call to the server, it's making call to the cache that you have stored locally, which is of course something you can clear if you've updated the imagery. We've had that before. But yeah, this is a fairly fast service and allows us to integrate aerial photos into any of our projects. All right, really quick, I do realize that we are approaching the end of this webinar. Sad, I know. All right, what if we wanted to do inspections on water hydrants? I think there's like 500 or 600 within Kamloops, and we have a layer, and we wanted to add a few things. So the first thing we're going to do is we're going to create a project with an OSM base map and the water hydrant. One of the things about this is that this took me literally maybe 5 minutes to build this app. So the process is really pulling the layer from PostGIS, you're turning it into a geo package. It just does that automatically with the MerginMaps tool. And then you're sharing it out to MerginMaps and starting to collect data. So I created a project with open maps. I'll show you what it looks like. If I go into the MerginMaps, I have a couple of apps that I built. I built one for hazard trees and I built one for water hydrants. So if I'm going to zoom in, here are my water hydrants that I built. And this is just a copy of the data that's now living within MerginMaps. It's not our primary data set, which is good. I added a few new fields. So you can see the new fields I added: inspected by, inspection timestamp, inspection status, and comment, and so on. And then I created an attribute form within QGIS. So this is how we create attribute forms within QGIS. And you can see I've given some options here. And then we have, then I sync the application with MerginMaps, and then I sync it to mobile, and then I survey. So let me show you kind of what this looks like. If I go into one of these points right now and I click on it, if I had editing turned on now, I can go inspected by, and I have Cliff, Amanda, Aaron, and I can select anyone. I'm going to select Sammy did this. And I have a drop-down menu, and I can say, Sammy did it today, and Sammy did it at exactly 8 o'clock, 8:07. And it was inspected, and we could say something like looks good as well. Now we have 2 points on the map that have been inspected. So we know that as they turn green, we're going to be happy and everybody's pleased. So I've made these changes as easy as that, because I'm doing the work within QGIS, not on the mobile app. I can press the sync tool at this point, and this is going to allow me to sync all the changes that I've made to MerginMaps. So this is just going to run. It's going to upload the project. It's going to tell us everything is happy, and we can press close. Now, anything that I open up in the app, I don't have my app connected during this webinar, but I will see those changes directly. And if you want more of a demo on MerginMaps, just reach out to us. I'd be happy to set up a little half-an-hour walkthrough and show you a little bit more how the mobile apps work. But let me give you a sort of a picture of what this looks like. So that one point that I created, not the one just now, but previously, this was inspected by me. I said, looks good, it's inspected, and I did it on the 15th of March. Likewise, in the app, this is what it looks like. We have the point on a map, and if we click on it within the desktop, we see this form. The same form exists. I would say this form looks a lot better, a lot sleeker within the mobile app. So this was done using an Android device, but it works on Android and iOS. So now we see everything. So I did this in a way that I could click on here and click on attribute data. There's tons of attribute data associated with each water hydrant. So I don't really want to see that. If the user wanted to, they could do that. So what's nice about that is that we create this tabbed interface. All we have is an inspection report. If you've inspected it, it's all good. You can populate a form just for that, and then put the attributes here. So this is what I was telling you about the version history. The first time we created this project, this is what MerginMaps looks like online. We see that this is the first version, and then we have multiple versions of the app, or sorry, of the data that's being used within the app, and all that is stored. And you can actually download these individual versions. If somebody screwed up, you can revert any of the changes, which is really nice. So one of the things, before I want to say that to you, is that oftentimes people be like, well, what if we want to bring the data into our application here? It's really easy to do that. So once you're done working with these data, you've updated and you want to store this, it's really easy to do something like, oh, I want to create a new schema called something like inspections. And once, oops, oh, it already exists. Sorry, I actually created it already. I have an inspection schema right here. We could import this water hydrant data into inspections, maybe give it a date and say this was the water hydrant survey of March 2023, put that in there, and then the data is saved within the database, and we can actually query it. We can look to see which hydrants have been inspected over time. It's a really handy tool once everything's in a database. All right, we're coming to the end. So if anybody wants to try this, try Geoserver, Postgres, PostGIS. Something we're offering for spring 2023 is to give you the opportunity to kind of have access to all of this and give it a go. So what we've done is we've given the advanced GIS server for 3 months at 50% off. Free basic implementation details, you can contact us for those, but we'll grab a bunch of your vector data, a bunch of your raster data, load them onto the server for you, but also show you how to do that. so you can do it yourself. You can add more data, and it's a fully functional server. It's the same one that we use with all of our clients. So you can do whatever you need within 3 months. It sort of gives you that opportunity to see how it works within your organization. And this is why we do it. 50% off 3 of our group training courses. So we do everything from intro, advanced QGIS, intro to Geoserver, and the course that I think everybody should take if they're adopting this stuff is QGIS and PostGIS in an enterprise environment. That'll teach you how to do all those things I showed you, like saving symbology within the map, running some basic SQL, spatial SQL. What I like to do when anybody is sort of moving into open source GIS is I do a weekly Q&A session with them. So this is just a half-an-hour check-in meeting that we'll do once a week throughout the 3-month period, where I can just answer some questions. And there might be just a few little things that you need cleared up, or you're wondering how something works. This is a really good opportunity just for us to have face-to-face once a week. And then in addition to that, we have 10 hours of support. That doesn't expire even after the trial period. So you're able to, use that for whatever you want. If you want us to use that for some consulting time and develop something for you and figure out a trigger function that will do this and this, so you can evaluate if this is going to be an effective solution, we can use those hours for that too. So with that said, just navigate over to lunageo.com/servers. We have a promo code, spring 2023. There's a little form at the bottom of the page. Do that. But likewise, we have our email up there, contact@lunageo.com, or, and of course, contact me directly at cpatterson@lunageo.com. If you're interested, we can chat. And if there's any questions, please throw them onto the Q&A and we can dive in. Does MerginMaps provide live data editing without having to sync? No, you do have to sync. So if you are moving something, like let's say you're editing a point, you're in the field and you move a point from one side of the street to the other side of the street and press save, you do have to press that sync in order to sync the data back to the cloud-based server. I have a private question that was just asked. How long does it take to migrate to an open source GIS server? That's kind of like how long is a piece of string? It really depends on how much data you have within your organization. So if you are thinking of moving towards open source GIS, one of the things I do with every potential client as we sit down and talk about their migration strategy is we talk about data. How much data do you have? What format is it in? Can you organize it for us so that we can then load it into the database? Things like this. And then anybody else? Okay, one more last question that somebody just asked is what happens after the trial period? So I guess you mean like, is there a commitment or something like that? Okay, no. After the 3-month trial period, you have 3 options. Option 1 is you can sign up for an annual license. We're very transparent with our pricing, so you can go on right now and check our server page and find out what the pricing is for a year for the server. So your other option is to continue just on a monthly plan if you want the server and backups or anything like this. And the third option is cancel, which would be unfortunate to see you go. But if it ends up not being the right solution for your organization, we always completely understand when that happens. Ooh, next question from Matt. Change management is hard, especially with long-term commercial users. Have you saw a municipality go full open source in Canada? Yes, I have. There's a number of municipalities. I don't know if I can name them. They're not my clients, but I do know they use them. I think a big one would be Toronto. Toronto's moving towards using QGIS throughout their organization. They've moved away from using a lot of proprietary GIS. They still use proprietary GIS from what I've heard. Again, not my client. But all new users are sort of being pushed more towards using open source GIS and using QGIS. There's a number within Alberta, a number within BC. BC Parks uses open source GIS. So they're using Geoserver, PostGIS, Postgres, and they manage like thousands of parks throughout that beautiful province. So it's used in all levels of government. It's just a question of if your organization is ready to make that migration, then we're always here to help guide that process. All right. Well, if there's no other further questions, thank you all for your time. This has been wonderful. I've enjoyed this. And if you have any questions that we didn't answer, just send me an email or find me on Mapstodon. Thank you very much.